Welcome back, guys. Hopefully you had some good luck on try these A and B. Let's run through those ideas first. So we were looking at page 526, try these A, letters A and B. The first one has a hemisphere, and they're asking you to find the area of a circle that is raised up on that hemisphere. And given the measurements that they have, basically what you end up with is a right triangle such that the radius was 20, because the whole length is 40 across, and it is 12 above. So really what you're looking for is that little X right there. Okay, and that is the quote unquote radius of that smaller circle. That smaller circle being like right here. Okay, and so you would do Pythagorean theorem, find out that radius is 16, and then in part B it asks you for the circumference and the area of that particular circular region. And so you would do 16 as the radius, your circumference would be 32 pi, and your area would be 256 pi, and you can always put that in a calculator and get a decimal answer. Okay, so here's what we're gonna do. We're going to look starting at page 526, and we're going to kind of work with the formula for the surface area of the sphere. The formula is 4 pi r squared, okay? So basically the area formula for a circle, and you just put a 4 in front of it. It's a very simple formula, 4 pi r squared, and so we're going to practice with that. As a math teacher, I don't have enough problems, so I made up some of my own, and so we're going to work these. These are some examples. And hopefully I'm going to work through these 4. It'll give you all different variations of the way the problem could look, and that way you can go to the book and work those problems there. So the first one we're going to look at says, find the surface area of a sphere with a radius of 5. And so we need to remember, what is the formula? Well, the formula for the surface area of the sphere is just 4 pi r squared. We take that 5, we plug it in for r, and so we have 4 times pi times 5 squared. 5 times 5 is 25, times 4 is 100 pi, okay? And depending on the problem, they might ask you for decimals. I'm not, generally speaking, I'm okay with in terms of pi. All right, answers in terms of pi, because that is the best answer you're gonna get. All right, second question. Find the radius given the surface area, okay? This doesn't change the way we're gonna start the problem. We're still gonna start with the formula, surface area equals 4 pi r squared. The difference is we're gonna plug into a different spot. We're going to plug in for the surface area. So I'm going to rewrite this as 36 pi equals 4 pi r squared. Okay, and we're going to solve for r. Now, remember back to Algebra 1, the way we would solve for this is we would divide by 4 pi. Okay, because remember backwards PEMDAS? D-E-M-D-A-S, and then we go this way. So we deal with multiplication and division before we get to that exponent. So we need to get rid of the multiplication. The opposite of multiplication is division. So we're going to divide both sides by 4 pi. The 4 is going to cancel, the pi is going to cancel, pi is going to cancel. 36 over 4 just gets you 9. So if we rewrite what we have going on, we've got 9 equals r squared. And from there, I think you can see pretty obviously that the answer is going to be 3. Not negative 3, because we don't talk about a negative distance. We're just going to get the radius is equal to 3. Okay, and with that, we could have done other things. We could have found the new circumference or the diameter or whatever, how big the box could be. They could fit in, things like that. But this is the setup. You go back to the formula. Okay. Number 3, if it takes a 10 pi length of string to go around a sphere, I know, kind of weird. Think 31.4 length is string, so 31.4 inches, something like that. To go around the sphere, find the surface area. Okay. So wait, to go around the sphere. So circumference. So this one actually requires 2 formulas. We're going to start with circumference formula. Circumference equals 2 pi r. And then we're going to plug in that length of string there. So we're going to get 10 pi equals 2 pi r. We're going to divide by the 2 pi, just like in Algebra 1. Divide by 2 pi. Pi is going to cancel. 10 over 2 is 5. 2 and the pi cancels. We get r equals 5. And then we're going to take that and plug that into our surface area formula. 4 pi r squared. But we said our r was 5, so we're back to a radius of 5, which is where we started today. So our answer is going to be 100 pi. All right. Last one. Again, I made these up so they're not perfect, but this is the idea. You have a square box. Okay. So we have a square box with a volume of 216. So square box, or a square prism, if you will, volume of 216. That means that this length, we'll just call this x, and this x, and this x are all the same. So volume is going to be x to the third equals 216. If you do the math there, you're going to find what number times itself is equal to 216. X is going to be equal to 6, meaning that this length right here is 6. Hopefully you're okay with that. And so if that length is 6, then if we're talking about the biggest ball that can be inside this box, that radius has to be half of that. So the biggest radius it can fit would be a radius of 3. All right. Now, radius of 3, we want surface area, so we go back to the formula. SA equals 4 pi r squared. We plug in our r equals 3 from our drawing over there. R is 3 because it's half this length, which is 6, and it's 6 because the volume was 216. Hopefully you can follow that. So we plug in 3. 3 times 3 is 9, times 4 is 36, and we get pi. So 36 pi. Now, these are all the exact same kind of problem, but all different, obviously, right? Some of them you're given certain information, some you're given the other. I don't want you to panic. All right, it's one thing, oh yeah, I know the radius, plug it in. Okay, cool. If you know the surface area, plug it in. Whatever you know, plug it in. Use the formula that they give you and the information that they give you to solve for what you're missing. All right, it's not complicated. You've got this. And here's what I want you to do. I want you to practice. You're going to go to page 528. You're going to do numbers 7 through 16. 7 through 16. We'll come back. I'll talk about those when we look at the next section. All right? Good luck, guys.